And now I think it's time that we go to the Q&A session. Okay, I hope it's visible. Let's see what we have here. Can you comment on the heap size requirements when using virtual threads? Do you need a larger heap size? And what is the idea of garbage collector algorithm using virtual threads? Okay, because the virtual threads will store their stack chunks on the heap, it can be that you need more heap space. That's reasonable. Yeah. So it can be that you need more heap space, but overall your Java memory will not increase, because also the traditional stacks are part of the Java virtual machine memory. Ram, do you want to comment on this? I see your face. Ram, you're muted. You are muted,
Oh, yeah,
Ram?
yeah. Thank you, Marwan. Yeah, so I just want to comment a little bit more on just this question, right? So, Marwan, can I share a screen just for a second? Is it okay? Yeah, I'll share the screen. So, Waji, the question just see, Marwan explained it, but I'm just giving a visual representation of this. See, our Java memory, right? If you see, our Java memory for the attendees of our session, they're familiar. See, we do have this Java process memory. It has two regions, heap memory, and then there is a native memory. Within this native memory is where the threads are stored. See, historically, if you have been using platform, when you just use thread, right? When you say new thread or when we do a new thread creation, they are stored in this threads region, which is part of the native memory. Now, when you are creating virtual threads, when the virtual threads are actually executing, they're going to use that platform threads, which is coming from here. But when they're not using, when they're in a blocked, they are going to be stored in this heap memory. So there is a, say, suppose if you're going to create a lot of threads, then your heap memory size will increase, but your native memory size will decrease, but your overall Java process memory will remain the same. But that is something you want to take into account. That is the heap memory, you may want to increase it, right? So yeah, so I'm now adding it back to Marwan.
Okay. So I will share the questions again.
Yes.
So should be visible. Ram, can you see the questions?
Yes, I can. Yes.
Okay, great. So we come to the second question by Waji Ahmed. Also, many applications use third-party libraries. So even if you modernize by virtual threads, bottleneck could be in third-party libraries. So what's the answer here? First, many third-party libraries offer virtual thread use by a switch. For example, Spring. For example, Quarkus. Yeah, there you have a switch. You switch over to virtual threads, and they use virtual threads. Fine. Then many third-party libraries just are thread safe, and they are run within threads. For them, it's a no-brainer. They just run then in your virtual threads, but you should make sure they have no problems related to that. So, for example, early versions of virtual threads couldn't handle synchronized blocks that great, but that was fixed. It was called pinning. There are, of course, some libraries who start platform threads themselves, but if they are reasonable libraries, they will have a good reason to do that. So there is not 100% yes or no answer I can give you on that, but modern libraries probably will support virtual threads when it makes sense. And on the other hand, it's not a disaster if you have libraries that start 2 or 3 or 25 platform threads in your virtualized thread system. That is not a contradiction. Sunil K. Recording shared, yes, can be shared. Ahmed Waji again. another issue, contention. So contention describes a situation where you have several threads waiting for a lock, right? And that is the same with virtual threads. So when they pile up in front of a lock, yeah, they pile up. But what's the improvement here is they release their underlying platform thread. So you have still a situation of contention where they block each other, but they do not consume an absurd amount of resources in your operating system. Yeah, so it's an advantage. Mustafa Kamal, please confirm my understanding. Virtual threads are not static in size. That is why they are cheaper, as operating system threads is always fixed in size upfront. Can you also explain how CPU registers are managed? So that question has two parts. Yes, virtual threads are not static in size. Platform threads are. Although the Java virtual machine specification allows threads to vary in size, in reality, all the most operating systems that we use, there we have a static allocation of the stack. There are optimizations in place. On my Windows machine, I have no problem starting 100,000 threads. Fine, yeah, but you should be careful. Yes, virtual threads have, in the beginning, no memory consumption, no significant. Yeah? They have stacked chunks. You can find the stacked chunk object in, it's a Java object. You can find it in the virtual thread class. And these stacked chunks are, with many optimizations, copied to and from the underlying platform stack. So they are lazy loaded and lazy swapped in and swapped out upon mounting and unmounting of the thread. So varying memory consumption and consequence ideal for short-lived tasks that do not need many method calls, because stack is the representation of the method calls. Second part of your question.
Actually, the question 7, the second part. Marwan, you have to look at question number 7.
Number 7, okay. Can you explain the CPU registers? Okay. The CPU registers. The CPU registers are the platform thread is the owner of his set of CPU registers. Scheduling of a platform thread, I would like to remind you to the picture that I've shown about the two threads that live in the memory space. Each platform thread has its own thread of CPU registers. When the thread is swapped out of the CPU, it remembers its memory registers, and when it's swapped in again, it writes the contents in the CPU registers. And that is, of course, some CPU overhead. So, but in the virtual thread case, you want the platform threads to run always. And in that case, there is not a lot of scheduling on the CPU, and you have no register handling. Question 8.
Marwan, before you move on.
Marwan, yeah.
Anya, 1 second. So, Marwan, before you move on, the 7, maybe the Kamal Mustafa's question, the first part, maybe I would like to rephrase it slightly differently. So a thread in Java, we can allocate a stack size, right? Using the argument like XSS. I can say it as a 1 MB. So I think Kamal's Mustafa's question is, let's say I start my JVM with XSS as 1 MB as my stack size. A platform thread, let's say it's actually, when it's executing a code path, let's say its actual need is only, for that particular code path, let's say it's only 250 kilobytes. So his question is, in the platform thread world, or in the platform thread, it will occupy 1 MB, irrespective, even though the need is only 250 kilobytes. Whereas the virtual thread will only occupy 250 kilobytes. It will not occupy the entire allocated 1 MB size. Is my question clear? Am I making sense?
Yes.
Okay.
Yes. It's clear. Yeah. You allocate the stack size that you can configure.
Yes.
But it won't be consumed. So it's lost.
Yes. So answer is yes. So Mustafa, your answer is yes. So if you're allocating XSS as 1 MB, then if platform thread only needs 250 kilobytes, that entire 1 MB is going to be reserved and it's going to be wasted. Whereas in virtual thread, if need is only 250 kilobytes, only the 250 kilobytes is used. Remaining 750 kilobytes will be saved. That is the one primary benefit we are getting here. Yeah, I think Anya, now you can ask what you're about to ask.
Yes, Marwan, you skipped 5 and 6. I just have
I'm sorry.
highlighted it.
So 5. This is a great explanation. Yes, it would be possible to receive the slides. 6. Slide 15 suggests that platform threads are actually used for virtual thread scheduling, but they are always running. Would this require a lot more CPU power? Okay, I'll have to go back to slide 15 to understand exactly what you mean.
No, actually, Marwan, you don't have to go. Waji, the CPU power, it will not consume. See, when a virtual thread is not running, it's just going to be stored as an object in memory. It's just going to be stored as an object in memory. It just occupying memory. There won't be more CPU power consumption.
Okay, fine. Let's go to 8. If there are enough blocked virtual threads, can the carrier threads be exhausted? I'm not sure if I understand the question right. Ram, do you understand the question?
Yes, I understand the question. David, if there are enough blocked virtual threads, see, first of all, when a virtual thread gets blocked, it will not take up a platform thread. When a virtual thread blocks, it will not take up a platform thread. It will just go to the Java memory and it will reside as an object. So it will not exhaust the carrier threads. Yeah.
Okay. Question 9. Does the virtual stack grow unlimited? No, it can't, because when the virtual thread runs, his stack chunks need to be swapped onto the real stack of the operating system thread. And this is limited in size. So when the CPU runs, it knows only the operating system thread stack or the platform thread stack. The stack pointer points there. So the memory chunks must be there. And that size is limited.
Yeah, good answer. Yeah, thank you.
Mustafa, does this mean platform threads are always in running state? No, but ideally they are. So the pattern of virtual threads is intends to keep the platform threads always running, but there is no guarantee for that. And always, anyway, doesn't mean always, because if you have a general purpose computer, there will be other threads, operating system threads, networking threads, user interface threads, and they all share the CPU. Yeah? Ideally, they should be kept busy, but they are not always running. Sometimes they are just runnable, but not running. Ratore Pratip. Oh, sorry. Mustafa Kamal. Why scheduling in vthread is faster than the OS? Because we talked recently, a few minutes ago, about CPU registers to be swapped in and out when I schedule an operating system thread. First. Second, scheduling with the operating system involves a system call. So a change between user mode and operating system mode or kernel mode. And scheduling of a virtual thread is just a method call in the JVM. CPU and operating system are not involved. It's just another method is executed. Yeah? So it's just one jump for the CPU. That is much, much, much cheaper. So now we come to question 12. Can you explain garbage collector behavior in virtual threads versus platform threads? Ram, I think that's your expertise.
Okay. See, actually, that's an interesting question. See, virtual threads, when they are not running, which is what the most of the threads are, they are going to be in the heap memory. But when they are running, they are going to be in the native memory. So basically, we are now, most of the virtual threads, we are going to push to the native memory. Sorry, they're going to push to the heap memory. But threads are not that many things. Even if you create 10,000 threads, which is not normal. Even if you create 10,000 threads, still 10,000 objects. They don't occupy that much memory. So in my opinion, there won't be any noticeable impact in GC behavior. That is my take on this. Okay.
Okay.
Yeah.
Question 16. In the old model, before virtual thread, context switch was considered expensive. Am I right in thinking that is still the case since the underlying platform thread still needs to load the context, CPU register, etc. before it can wake up a virtual thread? No. Interestingly, not. The registers do not change. The registers do not change because it's the same platform thread running. Okay, it has to. No, they do not change. Even the stack pointer, well maybe it gets a different value, but yeah, because it goes to another method. But there is no swapping of the registers in the CPU because the thread just goes on running. It just jumps to another method in Java. So from the perspective of the operating system thread, the scheduling between two virtual threads is just a method call plus swapping in those parts of the stack chunks that are needed. Ram, any comments?
No, I don't have any comments. Yeah.
Okay. So we go to number 17, Srinijak. By increasing virtual threads, do we need to increase the number of CPUs? How do we measure virtual threads memory and CPU consumptions? So I would go from the back. Yeah? If you are able to increase your CPUs, great, do that. Then you can use more CPU power. But virtual threads are great in a situation where you cannot increase your CPUs, but you want more scalability with the few CPUs that you have at hand. So you do not need to increase the number of CPUs because the idea of virtual threads is to optimize the time where threads do not use the CPU. This is where they are strong in. They do not increase computing power. That is very important to understand. They make it more efficient to block. So a thread blocks, it releases the memory it consumes, and is cheap. That increases the number of simultaneously concurrent tasks that you can have in your system. So you do not need to increase your CPUs. And second part of the question is, how do we measure virtual threads memory and CPU consumption? So you see the CPU consumption in your task manager as before, because virtual threads do only use CPU when they are running on top of an operating system thread. And about the memory consumption, yeah, that is a little bit more subtle because plus is the dynamic stack chunks. So there is a small memory, there is a memory overhead, and you can analyze that with the normal memory analyzing tools. For example, RAM, you have a memory analyzer as far as I know, and then there you can see which part of the heap consumption is related to the virtual threads stacks, right?
Yeah, see, it's going to be tricky to find the memory consumption exclusively by virtual threads, but it won't be that significant, in my opinion.
No, it won't be.
Yeah.
So, well, that is the best answer. So, virtual threads are great in the situations where you have no deep stack and no long running tasks.
Yeah.
And blocking. So, and there you do not have a lot of memory consumption. Yeah, the typical server application reads data from a database and serves it to the client, and that is the typical scenario. And the virtual thread itself doesn't introduce a memory overhead, because if you look at a typical thread, the expensive thing is the cold stack, is the stack, and the rest is neglectable. Yeah. And on my slides, you had several times the sentence, beware of deep stacks. And there it gets critical. So if your stacks are very deep, yeah, then there is, of course, no magic that can make them vanish. Yeah. If you have, and a deep stack means you have many method calls above each other. And that is typically a long-running algorithm. A recursive algorithm would create a deep stack. Yeah. Typical server would not create. It gets a client request, reads from the database, reads a REST call, does a credit card transaction, and sends it back. That's few hundred method calls. Or few thousand, yeah, but not a deep recursion. Okay, I hope that answered the question. So we come to question 18. Sai, why doesn't the JVM preemptively stop the virtual threads to prevent start? Okay, it's by intention. Yeah, preemption is nice, but it's not the only way to do a good scheduling. This model is optimized for this scheduling model is optimized for fast scheduling for the use case that I depicted, for short running threads. It's not ideal for long running tasks. It's not ideal for a number cruncher. It's not ideal for a general operating system where you need time slicing. That would be my attempt of an answer. But there can be other opinions. There can be opinions that say preemption is great. But preemption is not easy to implement within the JVM because for preemption, you need interrupts. Interrupts is something that you have on the hardware level and in the operating system. So if you remember the early days of Java, there were the so-called green threads that were the first threads in Java, and they were also not preemptive because it's not easy, I would say, probably even not possible to implement preemption without operating system involvement. And when I want to have this very fast scheduling approach that virtual threads provide, it's not feasible or advisable to bring in preemption. It's another scheduling model, but I'm happy for that question because that is sometimes overlooked, that I have here a slightly different scheduling. But don't be nervous. A normal application will not be hard because usually a thread doesn't run for hours without releasing the CPU, except number crunchers. Yeah, when you have CPU intensive stuff that needs preemption, or if it's implemented smart, it also doesn't need preemption. Preemption is important in an operating system scenario, or if you have several threads that do different things. But the use case that is favored here, server applications has blocking, and in case of blocking, the underlying thread is released. So we come to question 19. Or Ram, do you have something to add?
No. Good. Nothing more. Yeah, go on.
B. King Shuk. It's hard to know how deep a stack is going to be, right? Especially when using third-party. Right. Do you recommend analyzing stack depths before choosing to switch to this new model? No. I said beware of deep stacks, but well, that's a detail. Yeah, it's just something you have to keep in mind. When you have a performance problem, then you look at maybe that can be a reason. But use virtual threads. That's a great approach. That's for many applications. When you roughly have an application that fits into that spectrum, blocking, you benefit from more threads, use it. And you can analyze stack depth when you have a real performance problem. Yeah, do not analyze it in advance. It's something you have to keep in mind as a possible source of problems.
Yeah. Marwan, I would like to add something here, right? King Shwik. See, when you have a deep stack, you will get a Stack Overflow error. If you are getting a Stack Overflow error in platform threads, you will get Stack Overflow error in virtual threads. If you are not getting Stack Overflow error in platform threads, you will not get Stack Overflow error in virtual threads. So in my opinion, you don't have to worry about it. Today, if your application is running without any Stack Overflow errors, then you can switch to virtual threads. You will not run into Stack Overflow errors in virtual threads. Yeah. Go ahead, Marwan.
Recursion algorithms are quite limited in Java with a lack of tail cost optimization. So I'm not an expert in algorithm theory, but I'll do my very best to answer that question. So I think a smartly implemented recursive algorithm at some level, it stops to being recursive. Yeah. So you do this tail optimization yourself. And when you want to parallelize it, you stop parallelizing at a certain depth so that you have only a reasonable amount of threads. So if you parallelize quicksort, recursive algorithm, you can get the perfect performance increase. So if you have an 8-core CPU, you will speed it up by factor 8. And an advisable approach there are fork join tasks. But even with fork join tasks, you have to limit the depth of the forking of these tasks. Ram, comment from your side?
No, I don't have any additional comments. So.
Okay, that was recursion algorithms. Mustafa Kamal, what is the impact of garbage collection with virtual threads? Any specific advice?
Yeah, as we mentioned before, the virtual threads, in my opinion, it will not have any noticeable impact on garbage collection. So that is my take as of now. Okay.
Okay, Ram, what is the difference between scope value and thread local? So thread local has several drawbacks. It's not immutable, and I would say it doesn't scale that well, and it doesn't automatically inherit with the structured concurrency scope. So it's very nice when I have child threads from a structured task scope. They have the same scoped values. They inherit them. And they are safe because they are immutable. There are some other arguments, but these are the core arguments.
Okay, thank you.
What does pinned virtual thread mean? That is a very nice question. So when virtual threads were introduced, with Java 21 at first, as preview, or 23 as an official feature, they had an interesting drawback. Their core feature is to release the underlying platform thread once they hit a blocking call. But one of our most important blocking calls is the synchronized keyword. That's a blocking call. But when a virtual thread hit a synchronized, it didn't release its underlying platform thread. And even within the synchronized block, when there was a blocking call, the underlying platform thread was not released. And that was a somehow crazy situation. That was a shortcoming. And that is called pinning. A pinning is a situation where the virtual thread does not release the underlying platform thread, although it is blocked in the blocking call. And that is fixed now. So that is a major step ahead. Now, synchronized is not a problem with virtual threads anymore. So that is a very nice question because it shows us the advance that virtual threads have made in the past 1 or 2 years. That was a major shortcoming. Wait, for example, was affected because wait is a call that can only be called from within a synchronized block. And there are still some situations where we have pinning, and these are so-called JNI and foreign functions. So when Java calls external C++ or C code, and there is the blocking situation, then it's not guaranteed that the blocking releases underlying threads. Yeah. So, but the major issue were the synchronized blocks, and they are fixed. Does that answer your question?
Yes, yes. Thank you, Marwan.
Thank you for that. This question, yeah, shows us that this magical platform, Java, is evolving and solving problems. So when I looked at virtual threads in the beginning, I was shocked. It was like a joke, yeah. So, oh wow, they forgot to fix the synchronize or to have, it was a little bit ridiculous. It's like, Ram, you were asked recently after a talk, yeah, what's when the garbage collector has a memory leak, and then you were laughing and said, oh yeah, that would be a major problem. And this is a bit similar here. They gave us a thread abstraction that was not good with synchronized blocks. Yeah, that was a little bit ridiculous, but they fixed it. They fixed it.
Okay, thank you.
Okay. King Shuk, how do we control the number of platform threads supporting the virtual threads application? Yeah, you can configure the thread pool size. You can configure the thread pool size with a parameter. I don't have it in mind now exactly where you do it, but you can configure it. But ideally, you shouldn't configure it because the default size is the number of CPU cores you have. And you should just make sure that you keep your threads always busy. That's what you should do. You should not tweak with the pool size. That was number
25. You need to answer 26, Marwan. No.
Okay. Every MVC going to DB, every MVC can benefit from virtual threads. Model view controller, right? Or what's
Yes.
MVC?
Yeah, MVC framework, yes. Yeah.
Well, I would guess it can benefit, and if it's MVC by Spring, you just have a switch in Spring to use virtual threads.
No, Marwan, the question, the way I interpret is, there are a lot of MVC frameworks. All the MVC frameworks, they go to data, they make a database call, right? If a customer sign-on request, list, transaction history, payments, all of them go to database. In database, they wait for database to respond. At the time, they are not doing any work. So that is what the primary workload, right? In Java-based applications, there is a request comes, we make a backend call, we get a response, and then we send back. Will virtual thread will benefit that scenario? Answer is yes, 100% yes, because most of the threads are waiting for response on the backend system. So those threads are occupied. Now, when you replace the virtual threads, you're going to free up the memory. So answer is yes, it will benefit. Yes. 28.
Hayek, Walid. Is it worth to use virtual threads when we have a lot of native code like synchronized? I am referring here to virtual thread pinning on the platform thread. There are two ingredients to that question. If you have a lot of native code, I would be careful because in native code, pinning can happen. But you have another point here, like synchronized. And synchronized is not native code. Synchronized is implemented by the Java virtual machine. Yeah, so you can even find synchronized in your bytecode. Yeah, it's a bytecode. Monitor enter is the bytecode for synchronized, and synchronize doesn't yield to pinning. So two answers to your question. If you really have JNI calls, I would be careful. But if you have synchronized, you're fine.
Yes, because as Marwan explained just a few minutes back, the pinning was happening for synchronized methods in the previous releases. But now in the modern releases, it has been addressed. The virtual threads are not pinned for the synchronized calls. Marwan, was the fix was made in 21 or 24? Do you remember?
No, it's recent. I think in 24.
Okay.
Yeah.
Yes.
It's like half a year or so.
Yes. Okay.
So now we have an interesting question. Can we get a deadlock situation with virtual threads? Okay, I would say yes, because you can easily create a deadlock if you have two threads and two locks. The one thread acquires lock A, the other thread acquires lock B. The first thread, after it acquired lock A, tries to acquire lock B. The second thread, after it acquired lock B, tries to acquire lock A. And then you have a deadlock.
Yes.
Only thing that would be nice here, you do not block the underlying operating system thread, but your application still would not do an advance. Yeah, your application stands still, but well, it doesn't consume any memory. But so that was the answer with a small joke inside. Yeah, you got it. You have a deadlock, and that's a disaster, and the virtual threads do not fix that. Yeah.
Yes.
So.
29.
Sorry?
No, I'm saying question 29. Yeah.
29. Eshwaraja Vibhav, can you please explain the blocking calls concept of virtual thread? Not exactly able to understand it. Also, why exactly there is no CPU scheduling overhead to compare to typical operating system threads. Okay, this is two questions. I'll try, right? So, the blocking concept, can you explain the blocking call concept of virtual threads? So, the following happens. Your code is running within a virtual thread, and because it is running, it is also running within an operating system thread or platform thread. Yeah. Code is executing on the CPU. Then it hits a blocking call. This can be, the example from the MPC, a database call. Can be a database call. So then the libraries, the magic is in the Java libraries. Yeah? They realize, oh, it's a blocking call. And then they say, okay, once the call blocks, we separate the virtual thread from the underlying platform thread. And the platform thread then is able to execute another virtual thread that is currently available for scheduling. When the blocking call returns, and that means the data from the database is available, the environment gets a message from the synchronous I/O capabilities of the operating system and says, oh, okay, now the virtual thread is available for scheduling again because we have the data for him. And then it makes him runnable again, and it can be eventually be executed by an available platform thread and runs with the data of the blocking call available. Ram?
Yeah, go ahead.
Understandable?
Yes, yes.
Okay. So that was part one. And also, why is now CPU scheduling overhead? Okay, this answer is short. Scheduling between two virtual threads on one platform thread is a method call. No CPU action involved. It's realized within the Java virtual machine. Long story short, no CPU involved. No CPU involved is not correct because everything we do is performed by a CPU, but no context switch on the CPU involved. Scheduling between two virtual threads means a method call that makes other Java code being executed. And that's not easy to perform just in Java, so virtual machine participates. Okay, we go to the next question.
Yes. 30.
Molière Jerome, what about the current state of the tooling? Are tools ready to help dealing with virtual thread problems? Okay, the self-understanding of virtual threads is that the tooling can be reused because it's so close to native threads. But it depends on the concrete tooling you use. So, Ram, you have a comment because
Yes,
you are a
yes,
tool
yes.
provider?
I want to add.
Please
I want
take
to add
over.
to it.
Please
That's
take
a very good question, Jerome. That's a very good question. See, when we run any threading issue, the number one result, what we go is we take thread dumps to analyze, right? See, friends, the thread dumps for virtual thread support is evolving. It has gotten better, but it is not there where it should be. Marwan, I'm taking a screen and let me share it quickly.
Yeah.
See, friends, see, this is a thread dump. I've taken a thread dump from JDK 24. See what they have done now. Now here, they're saying this is that underlying platform thread. And now they are saying, okay, this is the stack trace of the platform thread. And now this is the stack trace.
I don't see your screen.
Oh, you don't see my screen? Thank you. Okay. Oh, maybe you have to do a screen stop the screen sharing, Marwan. Can you do that? Can you see it now? Anya, are you able to see my screen? Text editor.
Here I have someone else is sharing. Maybe I just have the wrong window open.
Anya, are you able to see my screen?
Yes, Ram.
Okay. Okay then. See, look at this. See, this is the thread dump, right? This is a thread dump, which was of JDK 24. See, now it has evolved, right? In the very early stages, in JDK early stages, look at this. They were just printing it like this. If it is a virtual thread, they used to add just say this as virtual, but there isn't. It didn't have all the details. But now in JDK 24, what they have done is it's getting better now. See here they are saying this is that platform thread, and this is the stack trace of the platform thread. And it says it has mounted this virtual thread, and this is the stack trace of the virtual thread execution. So this is a very good step forward. And we, as a fast thread tooling which analyzes the thread dump, we are supporting it. But there is one information it is even missing in JDK 24 thread dump is if a thread acquires a lock, that lock informations are not printed in the thread dump, which was present if it's a platform thread. The virtual thread, it doesn't say I acquired this lock, I'm waiting for this lock. That is really needed to diagnose blocked threads or a deadlock kind of issues. That is still not yet there. But when I attended the Java 1 conference, which was held in the Redwood City in the Oracle campus, I asked the architect, he told that feature is coming. Once it comes, then it will be a very concrete, complete tooling. So right now the answer is it is evolving. It has gotten a lot better, but it's not there where it should be. Okay, Marwan. Sorry, go ahead, Marwan.
Okay. Next question. Litwin list. If platform threads are busy most of the time, then surely CPU power usage will increase because the hardware cannot sleep the platform thread. Right, that's correct. Yeah, you will have a higher consumption, but usually you will be happy that you have that higher consumption because you do the computing that you want to do. It's higher consumption, but for something that you want.
Okay.
Kamal Mustafa. In a scenario with a mix of blocking and non-blocking operations, how does the JVM avoid pinning of carrier threads due to native calls or synchronized blocks? What strategies are available to detect and mitigate carrier thread pinning? So there is a setting that informs you about pinning. Yeah, you can give the JVM a startup parameter that when pinning occurs, you are informed. But pinning with synchronized is not an issue anymore. It's only in case of foreign functions and JNI calls. Kenneth Anderson, what are the scheduling rules for two virtual threads that become unblocked at the same? Great question. I don't know. It's a good question. I don't know. I think it's not defined, but I don't know. So the question, I rephrase it, when two virtual threads become unblocked at the same time, which can be when they receive interrupts from two different CPUs. Yeah, that's possible. Which of them will be scheduled first? I don't know. I guess it's not defined, but it's a good question.
Yeah, I agree, right? See, the question, it goes back. Even when a threads are waiting, it gets a notification call. Which thread is going to pick up and run first, right? We still don't know. It was not even answered in the platform threads world, the wait and notify. The same is true here as well.
I would take this question and give a general answer. You should never, as a general rule in parallel computing, never rely on timing between threads. The only timing you can rely on is the timing that you organize through your synchronization. Whenever you rely on a sequence, you will run into disaster because there is no time between the different processors. Things happen independently of each other. There is no sequence. And that is a very, very general rule. Never rely on timing. And if you looked at my slides, you could call me a liar because I often have something like sleep for a second and wait until something happens. This is bad programming style in a production system. Huh?
Yes.
But you find it all over the place. But this is bad.
Right. I think
never rely on timing.
Yes, I think that's a very, very good way to answer this. If you're doing for timing, yeah, I think you answered it very well.
So, number 34, Kamal Mustafa. I always wondered, JVM operating system thread, network cards, backend, NIC operating system JVM all the way works end to end. X, how the operating system wake up the right thread, a lot of questions follow. Okay, that's the device driver system of the operating system. The operating system, one part of the operating system is the device management and data coming in from devices uses the interrupt system to inform the operating system of incoming data, and the scheduler of the operating system is responsible to wake up the right thread that waits for incoming data. That was a very high level question. Yeah, you can go into greater detail here, but for now, the interrupt system of the hardware is tightly related to the operating system that manages these interrupts. The interrupts come from the devices. The device drivers receive the interrupts and propagate them to our application code by means of the operating system device driver layer. But that's operating system theory. That's interesting. You can go very deep there, but I hope I addressed the question at least on a high level. And that was the last question. Are there any further questions? Ram, by you, by other people in the audience?
No, I think those are the questions. I think, Marwan, thank you very much for answering all the questions very patiently. It was a very insightful, very refreshing talk from you. Thank you very much, Marwan. We really enjoyed.
Thank you, Ram. Thank you, dear participants, that you stood in the line so long. Yeah, we were vastly about our time. Thank you so much. I enjoyed talking to you. And yes, software world is small. Maybe we will meet in some context on a conference. You have my email address on the slide. I'm happy if you give me, if you have a question or a remark, you can contact me. That's fine. And said this, I would say thank you very much and bye-bye.
Okay. See you, friends. Bye. Bye.